Recording. Now we're recording. All right. So we learned the shortcut derivative method last week, which was 2.3. And now we learn two rules today, product and quotient rule. Just some rules for making certain derivatives a lot easier to handle. So the first rule up is the product rule. So this is the rule we'll use when we are multiplying two functions together. It says if f and g are both differentiable, then the derivative of f of x times g of x is given by the derivative of f times the derivative of g plus the derivative of g times the derivative of f. So to keep it really simple, I wrote it below. Just know this formula for product rule. F prime g plus g prime f. So that's all we're going to follow there. Okay. So when we do the product rule, of course, we're going to label our functions f and g. So this function, 3x plus 2 will be f. And then this function, 4x minus 5, will be g. And then I'm going to write them down below. F is 3x plus 2. And g is 4x minus 5. Now what we're going to do is take the derivative of f and g. So f prime is just going to be 3, and g prime is going to be 4. So we take the derivative of f, we take the derivative of g, and now we follow the product rule. So we're taking the derivative of g of x, so we're going to say g prime of x, and now let's go ahead and follow the product rule. F prime g, 3 times 4x minus 5, plus g prime f, 4 times 3x plus 2. Now, once you get to this step, the derivative is done, the product rule is done, calculus is done. All we have left to do is clean up algebraically. That's it. So from here, it's just cleanup. And I ran out of room there, wrote too big. So I'm just going to distribute that 3. So you'll get 12x minus 15 plus 12x plus 8. Clean it up, and we get g prime of x is equal to 24x minus 7. And there it is. That's how you would use product rule. Any questions on that?
None here.
Got a thumbs up. Sweet. Okay, so that's it. Label F, label G, take the derivatives, follow the product rule, clean up algebraically, and that's it. So let's go ahead and try it again. Oh my. Okay. 2. Now I'm going to write a little smaller. So again, we have 2x squared times 3x to the 4th minus 2. 2x squared will be my f, and 3x to the 4th will be my g. F is 2x squared. G is 3x to the 4th minus 2. Take the derivative of f, and then take the derivative of g. All right, take the derivative. Now follow your product rule. We're taking the derivative of f of x. So we start with f prime of x, and we go f prime g, 4x times 3x to the 4th minus 2, plus g prime f, 12x cubed times 2x squared. Okay, and once again, derivative's done, product rule's done, calculus is done, algebra from here on out. And we'll get 12x to the 5th minus 8x plus 24x to the 5th, which will get 36x to the 5th minus 8x. There we go. All right. Any questions on that one? Good, good, good.
I feel like I missed something real quick.
Go ahead.
Just need a quick overview of the getting the derivative from f and g.
Mm-hmm. Like, how did
you
this
get from
become that, or?
Yeah.
Oh, okay. So last Wednesday we did the shortcut derivative, right?
Right.
So if you're ever given a power function of something to the nth power of x to the nth power, whatever n is, then the derivative is n times x to the n minus 1. So this means that the derivative of x squared would be 2x to the first, or just 2x.
Okay.
And then
So
if
for
it
g, 3x to the 4th minus 2, would the minus 2 come into play at all or no?
good, so the minus 2 is a constant. So the derivative of any constant is always 0.
Gotcha.
Got it? So if I said d over dx of some constant c, then that would always be 0.
Okay.
All right. All right. Okay, let's try it again. 3. Y equals x squared times the sine of x. X squared will be f, and the sine of x will be g. So here, f equals x squared, and g equals the sine of x. And then take the derivatives. F prime is 2x, and g prime, what is the derivative of sine, guys?
Cosine.
Cosine. There we go. Derivative of sine is cosine. Okay. There's f, there's g, there's their derivatives. Now let's follow the product rule. We're taking the derivative of y. So I'll just say y prime and follow our product rule. 2x times the sine of x plus cosine x times x squared. Okay. Of course, another way to rewrite that is just 2x sine of x plus x squared cosine of x. And if you wanted to simplify it one more time, what could you factor out?
X.
Just an x, right? So this is perfect. But remember, always practice your algebra, and you could factor out an x, which would give you x times 2 sine of x
Howdy.
plus x
No.
cosine x. Okay. So however you want to go about it. All right. Everybody good with that one? All right. Thumbs. I see thumbs. Good. Okay. Well, let's do it again. Number 4, product rule. Sine theta will be my f. Cosine theta will be my g. So here, f equals the sine of theta G equals cosine theta. And now derivative of f is cosine theta, like we saw in the last one. And what is the derivative of cosine?
Negative sine
Negative
theta.
sine theta. Okay.
Okay.
All right. And now to play with notations, we're taking the derivative of y with respect to theta. So we're going to say dy over d theta equal to f prime g. Cosine theta times cosine theta is going to give me cosine squared theta. And then g prime f. So plus negative sine squared theta. Or I'm just going to make it minus, right? Since it's negative. So I'm going to say minus sine squared theta. Okay. Now this is an okay answer, but does anybody know the trig identity for cosine squared minus sine squared?
1.
That would be if it was
Oh, plus. Sorry.
plus. I'll Venmo you $1. Not you, Ryan. You're on your computer. Google it.
Cosine 2 theta.
That's it. Cosine squared minus sine squared is also the double angle formula for cosine 2 theta. You see how identities come back to haunt you?
Yeah. I'm gonna need to expand my trigonometry cheat sheet.
There you go. I mean, if you're on a computer, just Google trig identities or trig formulas, and bam, it'll all pop up, right?
Or keep all the math notes you've ever taken and, just like look through them or something.
Oh yeah, you can reference my pre-cal notes on the OneNote page. That'll help you out too.
Yeah, sure. That's what I was talking about.
Yeah. I mean, you said one, Amanda, so.
Listen, I've drank a lot since then.
Haven't we all? All right. Any questions on this one before moving on? All right. Okay. And like I said, the first one I boxed is a suitable answer, but hey, why not just practice seeing if you remember that identity? Okay. Oh, hey, that was the end of product rule. Not bad, right? So again, just label what f and g are, take f and g's derivative, follow the product rule, f prime g plus g prime f, and then simplify algebraically. And that's it. So any questions on product rule before moving on? All right. Thumbs up. I'll take it. Okay. Next is quotient rule. So it's when you're taking the derivative of a quotient. So it has the derivative of f of x over g of x is given by the derivative of f of x times g of x minus the derivative of g of x times f of x over g of x squared. Or to keep it really, really simple, f prime g minus g prime f over g squared. So once again, we're going to label f, we're going to label g, we're going to take their derivatives, and now we're going to follow the quotient rule formula. So for quotient rule, the numerator is always f, the denominator is always g. So let's go ahead and get started. Maybe have to write really small in this one. So this is going to be, whoa, F, and this will be G. Down below, I'll write it. F is x squared plus x minus 2. And G is x cubed plus 6. Take the derivative of F, and we get 2x plus 1. Take the derivative of G, and we get 3x squared. All right, there's F, there's G, there's derivatives. Now let's follow the quotient rule. So we're going to say y prime, and now it's going to be f prime g, 2x plus 1 times x cubed plus 6 minus g prime f, 3x squared times x squared plus x minus 2 all over the original denominator, x cubed plus 6 squared. And that denominator, the original denominator, is always squared. That's just how the formula has it. So now the derivative is done, the quotient rule is done, and all we have left to do is clean up the numerator algebraically. So we're going to have to FOIL these two guys, distribute these, and then combine like terms. So from here on out, again, purely algebraic. Okay, so equals, what's that? 2x to the 4th plus 12x plus x cubed plus 6 minus 3x to the 4th minus 3x cubed plus 6x squared. All over the original denominator squared. Okay. Clean up one last time, hopefully. I have 2x to the 4th, negative 3x to the 4th, so negative x to the 4th. And then I have x cubed, negative 3x cubed, negative 2x cubed. And then we have our squares, which is just that guy, plus 6x squared plus 12x, that's what's left over there, plus 6. I thought more terms are going to combine. No, and that's just going to be as ugly as it is. Over x cubed plus 6 squared. And there's nothing else we can combine in that numerator.
You wouldn't want us to like square the bottom at all. You could just leave it like that.
Never, ever FOIL your denominator unless I say so or you really, really want to.
Okay.
Yeah. So if you want to FOIL that out, go ahead. That's just an extra step, though. We just want to clean up the numerator, and that's it. All right. That is quotient rule. Yes, it left off an ugly answer, but there's nothing else we can do. So any questions on that process? Yeah, that's just ugly as it is. Okay. All right, then. Next one. Numerator is going to be f. Denominator will be g. F is x squared plus 1, and g is 2x minus 3. F prime is 2x, and g prime is just 2. Taking the derivative of f of x, so we'll start f prime of x equal to, and then f prime g, 2x times 2x minus 3 minus g prime f, 2 times x squared plus 1 all over the original denominator squared.
What do you want to throw it at him?
All right. So once again, there's f and g, derivatives done, calculus done. The rest is clean up the numerator. Okay. Distribute that 2x, so 4x squared minus 6x minus 2x squared minus 2 over the same denominator. And then final cleanup, 4x squared minus 2x squared. We have 2x squared minus 6x minus 2 over 2x minus 3 squared. And in a hope that we can go further, what could you factor out of the numerator?
A 2.
Just a 2. And let's see. You get x squared minus 3x minus 1 over 2x minus 3 squared. Okay. And can we factor the inside trinomial? Are there any factors of 1 that can make 3?
No.
No. So that is done. All right. Any questions on that one?
No.
No, just no. Okay, cool. All right. Let's keep moving then. Next is y equals the tangent of x. So if we are going to use quotient rule on this, we need to change tangent into its quotient identity. So what's another way to write tangent?
Sine over cosine.
There you go. Sine over cosine. Which means that sine will be f, cosine will be, oh goodness, cosine will be g. So f is the sine of x, g is the cosine of x, and then we go f prime, which is cosine, g prime, which is negative sine of x. Okay. Doing quotient rule, we'll start with y prime, and we do f prime g, which is cosine squared x minus, and then g prime f, which is going to give me negative sine squared. So that means the middle term, or the middle sign, is going to become what?
Positive.
Positive. So I'm just going to write positive already. cosine squared x over the original denominator squared. So you can have cosine x squared. And now here's where you come in, Amanda, because what's cosine squared plus sine squared?
It's a double angle formula, right? I'm just kidding. It's one. I'm just kidding. I'm sorry.
I was like, no. So cosine squared plus sine squared, we know is 1. So we get 1 over cosine squared x, which is what other identity? Now this one we can't leave like this. We know we can rewrite it. So what is the identity for 1 over cosine?
Isn't it secant squared?
There you go. Secant squared x. So look at that. This is going to be called, so remember we had trig limit identities. Now we're going to have trig derivative identities. So we know now that the derivative of tangent is secant squared.
Oh no, it's gonna get more complicated.
Oh, never, man. If you can prove these by a quotient rule and product rule, you're fine.
Yeah, probably.
Just have your trig identities out somewhere. Post them on the wall right in front of you, right?
Yeah,
Use that wall space.
I'll mail my old trig cheat sheet to the wall and I'll start another one.
There you go. That's how we do it. And like so many things, right? But just know, like, we don't memorize things. Because if we can make them, we don't have to memorize them. And you can make all of the trig derivative identities either by quotient rule or by product rule. All right, except for sine and cosine. To find those, you'd have to use the definition of the derivative. Okay. So on the next page, and look, I've made it easy for you. You can put this on your wall. Here is a table of the trig derivatives. So we know that the derivative of sine is cosine. We know that the derivative of cosine is negative sine. And now we know that the derivative of tangent is secant squared. The ones we don't know yet are these ones, which are written out already. The derivative of cosecant is negative cosecant cotangent. The derivative of secant is secant tangent. And the derivative of cotangent is negative cosecant squared. So those are the remaining 3 trig derivatives. Okay, so what we're going to do next is just prove the derivative of cosecant. We want to prove that the derivative of cosecant is equal to negative cosecant x cotangent x. So this is going to be somewhat like the tangent one we just did. So I'm going to start this off by writing d over dx of the cosecant of x. And in order to take this derivative, well, what is another way to rewrite cosecant?
1 over sine.
There you go. 1 over the sine of x, which means now we have a quotient, which means we can take the derivative by using quotient rule. So the numerator will be f and the denominator will be g. And here we get f is 1 and then g is the sine of x. Now f prime is 0 and g prime is cosine. Okay. Now, since this is just the derivative of a trig expression, we have to rewrite it as we start with d over dx of cosecant x is going to be And now we do our quotient rule. F prime G, 0 times sine, 0, minus G prime F, cosine of X, all over the sine of X squared. Okay. And now derivatives done, quotient rule is done, calculus is done. Let's go ahead and algebra and trig on from here. So we know that this becomes negative cosine X over sine squared X. What can I do to make this look like negative cosecant cotangent X? How could I rewrite this?
So cosine over sine is going to be equal to cotangent, and then you can so
put a cosine over one sine?
yeah,
Okay.
and then multiply that by 1 over sine.
There you go. We can split it like that, right?
Yeah, which is
Good.
effectively negative cosecant over negative cotangent over
Cosecant,
cosecant.
which is the same as above. You can rewrite it either way.
Yeah, I suppose the negative can go anywhere if it's multiplication like that.
Well, remember that multiplication is associative, so you're
Yeah.
able to rearrange the terms.
Yeah.
So that means that this looks like that, just written in a different order, which means we have proven by quotient rule, by derivatives, by calculus, that the derivative of cosecant is negative cosecant cotangent X. Doesn't that feel good to prove things?
Yeah.
Yeah. Okay, guys. And that is product rule and quotient rule. Any other questions on these notes?
Yay!
Not bad, right? Just keep moving now. One more lesson. Yeah, right. All right.